Hey everyone, welcome back to DIY Chris. I'm Chris, and it's been a long time since a video, but I'm gonna attempt to make it not a bad one. So, what are we doing here? I have a Commodore 64, obviously, that a customer had sent to me, and so I did this a little differently. This time I did the troubleshooting first, and now we're doing the video after. So I already know what's wrong with this, but I just wanted to show you guys really quick um, how you would go about fixing something similar. And it's not always going to be this problem, but in this case it did happen to be this problem. So what I'm going to do first, I'm going to turn this on. And what you'll see here are just, these blue lines going across the screen, black. And it may not be obvious at the very beginning, what could be causing this. But much like a black screen, the PLA is it's just something that goes bad a lot. And I would always start there to try, if you can, remove the PLA. If it's socketed, especially if it's socketed, you're going to want to work on that first. And as you can tell, I've got most of these chips are actually socketed, so that's really, really good for me. So I'm just going to go ahead and remove the PLA. And we're going to put a replacement in. And these replacements are replacements that I make. They are PLS 100 equivalent, which is the first iteration sort of the PLA that Commodore made before they created their own using MOS. But so before that, they used the PLS 100. What we're going to do now is we're going to go ahead and turn this back on. And you'll see that we now have the screen that we're after, which is the blue screen with the ready prompt, and everything looks great. Perfect. So the next thing that I usually do at this point is, I feel like I have a working system. So the best thing that we can do now is we take a diagnostic cartridge, and we're going to go ahead and plug that in. And I'm not going to worry about the harness just yet. I don't usually add the harness in until I have the machine pretty much working the way that I want, and the harness just helps me find those last few things that might be an issue, such as maybe one of the CIA chips is having a problem, or something else on the board. So let's go ahead and do that. Turn that on, and so you'll see it's running through its thing there, and we're just going to let it run for a second. See if you guys can spot something else that might be wrong. Doing RAM tests. All looks good so far. All right, test the sound. Doesn't sound right. Yeah, so what we have is a failing SID chip. So unfortunately, these also produced by MOS are just prone to failure over time, and which is really sad because you can't get replacements for these anymore like you can with the PLAs. The CPUs can be replaced, even the CIAs have been reproduced, but the SID chips, they are hard to reproduce because of the way they're manufactured, because they're partly analog, and all of these different ways that people have tried to recreate these devices are using digital only logic chips, and it's just it makes it very difficult. Okay, so I have here a SwinSID, and that is actually one of the recreated chips that we can use to emulate the SID chip. And let's go ahead and see if that sounds any better. Okay, so that ding that you just heard in the beginning, that's actually sort of the signature sound of the SID. Anytime you can hear one of those dings when you first turn on the Commodore, that was put into the firmware as sort of a thing that this SID does. We'll go through the RAM tests. All right, moment of truth. Cool. So the other thing that the customer wanted us to do while we had the board is to replace the electrolytic capacitors, since they are prone to leaking over time. It's just a good practice to remove them and replace them with newer capacitors that you know just kind of extend the life a little bit. And we're looking at is most of these ones here are all 10 microfarad. So we're looking at 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. There are, I believe, 2 under here. There's a 100 microfarad. Then we got a 2200 microfarad, a 470, and a 1000. And what I like to do is I just like to replace the 470 with a 1000 as well. So what we're going to do is we're going to use this set here. So I've got a 100 microfarad here, a 2200 microfarad, and then 2 1000 microfarad. And also I like the color orange, so we'll go with that. I'm going to go ahead and turn this off now. And we are going to go through and remove the RF shield first, before anything else. Get all this other stuff out of the way. Turn on our desoldering iron. All right. And the way that we need to do this is we've got these tabs all around the board that we need to heat up with the soldering iron. And from there, what we'll do is once they're heated up, we're going to bend them back, and then we're going to remove the shield so that we can get to the underside of the board, so that we can actually remove all of the capacitors. So we've got the soldering iron heated up, and let me see, there's something that I usually have here that I like to use. All right, very, very useful tool. Okay, so 2 ways you could do this. You could just literally hold the soldering iron onto the tab, and eventually it'll heat up. Or what I like to do is I like to actually add a little bit of solder, and that actually speeds things up a little bit. So you get it all nice and heated up, and then you just kind of bend it out like that. And we're just going to go through and do every single one of these. Do these over here, and I apologize in advance if at any point this goes out of the frame. It's I actually don't see what the camera sees, so I'm just hoping that I stay in frame. Yeah. That one, And let's grab this one over here. And let's turn it around. And all we have left is this one, and then the one on the RF modulator. That one's probably one of the more tough ones to desolder. A lot of people just clip it off. I don't like that idea. This one's a little tricky. I can't get this tool into here, so I'm going to use the tweezers. Okay, get that one. Okay, so now for this one, because this thing right here, the RF modulator, actually sucks in all the heat, it definitely helps to continuously add solder to this. It's just going to help with the heat transfer. Yeah, so eventually you're going to have all of this. There we go. Now we should be able to remove. There we go. Perfect. Interesting. I always wonder, like, has anyone done anything, any sort of work to this since it's, left the factory? Potentially this has not been worked on by a human since it left the factory so many years ago. It's just kind of cool to think about. So what we have now is the bare board. So the other thing we need to do is we need to remove this shield here, and sometimes this thing is a little more difficult to remove than others. But yeah, see, we have two two more electrolytic capacitors here. And so the desoldering commences. So sometimes this can get a little difficult because you don't always, it's not always very easy to tell on the backside where the pins for those capacitors are. So it's a lot of looking, back and forth, right? Obviously, if we look here, this one is probably these two here. Like I said, I like to replace the 470s with 1000s, mainly because it doesn't matter. But because I can't find these 470 in the way that I like them. So anyways, we've got negative going that way. So one way to tell, not everybody knows this, but if if you're going to work on these, you should pay attention to some of these things. Number one, these are polarized. Okay, so that means that you have to make sure that you put the positive where the positive goes and a negative where the negative, right? So if you look at the board, you'll see that the silk screen basically gives you all the information that you need to make sure that you orient these properly. If you look here, the square, right? Number one, this is a square, and this is a circle. Okay, square, circle, square, and that's the plus. That's the positive. Most times, number one, the square means it's the first lead. If you're using like an IC, pin 1 is usually signified by using a square, sorry, a square pad, and all the other pins are circles. When it comes to capacitors or anything else that's polarized, you're always, the anode is going to be the plus, the square. The cathode, meaning negative, is always going to be the circle. Okay? Even if you look at these other capacitors here, everything that has the plus is a square pad, and all of the negative is a circle pad. So I like to line these up, and I like to orient these so that you can read the actual microfarad that are on here, and I like to make sure that they're in the center, and then I grab these little needle nose, and then I hold where the hole is, and then I just bend them over like that. Okay. And I put one end in just to make sure it's where I want it to be. Then I mark the other spot and bend that one in as well. And it's got a little crooked, so I'll make that straight. Okay. And since we already have our template now, let's go ahead and do the same thing to this other guy here. Okay. So these should go in pretty well. And as far as being able to tell on the capacitor, it'll actually point in the direction of where the electrons flow, right? So I'm going to go ahead and bend these so the capacitors will sit while we solder them back in. So let's go ahead and do that. All right, I'm going to go ahead and clip these. And here we have them. Looking pretty good so far. Okay. Now this one. This one, on the other hand, is pointing in the direction of the positive end. So we need to make sure, again, that we follow the direction. And let's see, we got 2200. So positive is going to be this way. And bend this in. that one in. And then that's just going to go in here. Just like that. And we're going to go ahead and solder that. All right, now this one, the 100, same thing. This one, actually, the way that you tell on these smaller ones is this one here, the black stripe. You'll see this has like a little line in it. That means this is a negative side. And also, the lead is shorter. On most capacitors that you find, the lead that is going to be the negative side is going to be the shorter one. And that is pretty much true for almost any passive electronic component. The lead that is the shortest one is going to be the cathode. But still, double check and make sure. Okay, this hole could be a little more open. So my desoldering gun likes to go into sleep mode if I don't use it for a little while. So we gotta wait for that to heat back up. Should only take a second. Maybe a little longer than a second, but not too long. There we go. Okay. There we go. Perfect. So again, negative side, positive goes over here into the square. Push these down. And let's go ahead and solder. Cool. Awesome. Okay. That takes care of this side of the board. And now what we need to do, and actually just move all of this stuff out of the way. Okay, where are we? Here. Okay. This one too. So now that we have, I don't think we have enough of these. We should have 14. I think I only grabbed 13. Let's have a look. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Let me grab one more. $14. Okay. All right, so with these, I just like to kind of populate the entire board and then solder them all in at once. So let's go ahead and do that. Again, I'm only going to make sure that we look at the negative side and stick that side in that is not the square pad. All right. I guess let's count the ones we have. and see if it did count wrong. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 it is. Okay. Cool. Let's solder them in. And I like to count these as I do it so that I don't accidentally miss one. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. All right. There we go. Back together in one piece. So let's go ahead and make sure that it still functions. I'm going to go ahead and plug in power. And let's grab the video cable. Let's turn this on. And we're still good. Perfect. So I'm going to go ahead and reattach the shield. And then we'll just really quickly test the keyboard and make sure everything is good there. Right. Cool. And let's put this back in its case. And we've got the screws here. These longer ones are the case screws, so don't try to reattach the motherboard with those. Actually, there's something else that I wanted to mention. This this was attached originally. I'm leaving this off. This literally is a heat trap, and it's going to not allow these chips to breathe like they should. So let's make sure that we don't put these things back on. Let's make sure this thing still turns on after reattaching the heat shield. The RF shield. I don't know why I keep calling it the heat shield. Anyways, so turn this on. We're still good. Awesome. So next order of business, we need to plug this keyboard in. And I need to check and make sure that it works like it should. So I'll plug the keyboard, and then we'll the LED. Okay. And then the tabs. Just gonna go in there like that. Alright, this is all together. So let's go ahead and it's gonna be a very, very simple keyboard test. I don't use an application or anything like this to test the keyboard. I just literally type the characters. B. So look here. C, D, E, F, G, H, I, J, K, L, M, N, O, P, R, S, T, U, V, W, X, Y, Z. 5, 6, 7, 8, 9, 0. And then obviously shift lock. The A is a little just have to press a little harder on the A. But you know what? These are things that I had to deal with when I was a kid. It's just God, can't do it. I have to. Like I don't feel right about I don't feel right about returning this without fixing this key. So bonus, you guys will get to see how I fix these keys. So we don't have to remove the keyboard from the outer shell. We just have to remove this. So let me see if I... Okay, should be good. All right, so a couple things. Let's remove this tape. This is probably the easiest that tape has ever come off. We need to desolder this. Shift, caps lock, shift lock. Okay, simple. And now we need to take out all of these little screws. And this is why I don't like to do keyboard stuff, because it is a lot of screws. All right, pull that out. Okay, so the good thing is because all the keys are still on, I can literally do this and they won't fall out. Otherwise, all of these little things would fall right out. And so we need to go ahead and take the A key off without breaking. There we go. Okay. Actually, I'm wondering if, you know what, let's do a couple of things here. I'm gonna clean this board off with a little IPA. Since we're not working with the carbon pads, we can do that. Be surprised, a lot of the times that will just fix the issue. But we can also make sure that it's not the little carbon pad on the plunger. You can check the resistance on this. I'm thinking within a couple hundred, just a little, like around 100 or 130, 100 and... Yeah, so this seems fine. Yeah, the resistance on this is pretty normal. So maybe this just needed a cleaning. So we'll go ahead and try to put this back together. And before we put the whole thing together, I'm just going to put in a few screws, enough to test and see if this made any difference. Okay. Let's bring back the Commodore. Let's have another look at the A. See if it's better. Much better. Okay. That I am happy with. So let's go ahead and put these screws back in. Putting them in is actually a lot more frustrating than taking them out. So I may fast forward through this part. Okay. We get to actually reuse this tape, which is not anything that I've ever been able to do before. And then we're going to reattach the shift block. And the way I like to do that is I just, because there's a hole here, I like to stick these in first, get them started, and then I can heat up the side and just kind of push it through. And there we go. Okay. Now we're going to go ahead and plug the LED back in and close it up. And let's go ahead and turn it on. Okay. I am happy with this. So let's go ahead and put in the final 3 screws. So the last thing that I do with any repair that I do is I connect the diagnostic harness, put in the diag cartridge, and let it run for 2 hours. Just to make sure that no problems creep up or anything like that. I'm not going to subject you guys to that. And I wouldn't expect anyone to sit through a 2-hour diagnostic, but you know, who knows. Anyways, so this will be the end of this video. I'm going to probably upload another one shortly after that is going to be another customer repair. I actually have quite a few customer repairs in that I'm trying to get through. I've been had a little bit of a backlog, and so I'm trying to get through all of that. I've actually had people specifically requesting me to record their repairs, which is cool because, you know, as a person who is getting something fixed, seeing it actually get fixed and how that happens is really, really cool. So I can understand that. So again, end of the video. Hope you guys enjoyed it. If you have any questions, feel free to leave comments down below. If you have a Commodore that needs to be fixed, feel free to get in touch with me via the website, and we can work something out. Beyond that, we'll see you guys next time, and that's it.